All right, I'm all wired up, and I'm going to be your last speaker today. I'll never make it through airport security with all these wires on. It's really nice having Michael and Michael's group here to do some really cutting-edge research in terms of tall fescue toxicosis. We're starting to understand things that we never have understood before. My talk is going to kind of wrap things up and bring things together in terms of a management approach to tall fescue toxicosis. And you're going to hear some things that you've already heard today. And I think that's okay, because generally speaking, you need to hear things about 3 times before you actually remember them. So we'll go through this, and then the plan is after my talk is over, when we take questions, we'll bring everybody, all the speakers back up and take questions on any topic associated with tall fescue toxicosis. All right, I'm going to be using a chart today, and that chart will be on the slides, but it's also on page 49. So if you're in the back and it's a little bit hard to see that chart, you can always look at page 49 in your proceedings. So my topic is practical considerations for utilizing tall fescue and grazing systems. And we have spent a lot of time talking about the novel endophytes, so I'm going to talk more about the novel endophytes because they are a real solution. But that may not be a practical solution for your farm. In fact, in most of the farms in here, it may not be a practical solution at this point in time. And we're going to talk about how to make that decision as we move forward. So today we're going to talk a little bit about a strategic approach to utilization. One of the speakers in the Beef Efficiency Conference defined strategy and tactics yesterday, and he did a nice job doing that. And really what I'm talking about is kind of making a plan of how we're going to manage that tall fescue toxicosis. And then we'll talk about considerations for replacement of endophyte-infected stands on your farm or toxic tall fescue stands. And what we should be thinking about when we make that decision to replace it or not to replace it. We'll talk about replacement strategies real briefly. Dr. Lacefield did a nice job talking about strategies for getting that novel endophyte tall fescue into pastures successfully that are infected with the toxic endophyte. And then we'll talk about management strategies. So not all farms are going to want to replace tall fescue stands. On those farms, we got to think about how are we going to manage those stands to mitigate the negative impact of the endophyte in your cattle production system. And then I'll just finish up with a flyer from the novel endophyte workshop that Ray visited with you about. So this is kind of the top on the diagram. So if we want to make decisions, we've got to know kind of where we're starting at. And the starting point with tall fescue toxicosis is that we need to know whether our animals are experiencing toxicosis. You can tell by looking at your animals, are they under heat stress in the summertime? Are they standing around the pond when it's 60 degrees out? Do they have a rough hair coat? Are they laying down in the mud and covered in mud? Those are all good indications that they're experiencing some level of tall fescue toxicosis. A way to quantify that is to take a look at your pastures, at the infection rate, the endophytic infection rate within your pastures. And you do that by gathering tillers or stem bases of the plant, sending them into a lab, and we do that at UK Regulatory Services. And there's a publication after my article in the proceedings on how to do that. And we test those tillers for the presence of the endophyte. If you don't know that you have the endophyte, chances are you probably have it if you know that you've never planted a novel endophyte or never planted an endophyte-free tall fescue. Your pastures are probably infected with the toxic endophyte. All right, so we're going to get the results back, and we'll use those results now to make some decisions. So if we have less than 20% endophyte infection in our pasture, so 20 out of 100 plants are infected, then that's a low infection rate. And we're going to say we really don't need to do anything right now except manage our pastures with our best management practices. If we have more than 20% of the tillers infected, so 20 to 25%, then we start to get into what we call the high endophyte infection rate. And then we'll start to have to make some decisions. So if we're less than 20%, we'll keep that stand, okay? Simple, keep the stand, and we just use best management practices. We make sure our stocking rate's right. We soil test like Ray talked about. Make sure that if we need lime to get our pH up, we put that lime on. We use a good grazing methods. We frost seed some clover in there to increase the nutritional value of our pastures for our cattle and bring nitrogen into our grassland ecosystem. And then we work at extending grazing. And I'll just mention real quick, we had a great conference this fall on extending the grazing season, 2 locations in the state. If you didn't get a chance to go to it, you're in luck because we've got all those videos on our YouTube channel and you can go back and watch those videos. Okay, so keep the stand if we have a low infection rate. Now we move into this other side. We have a high infection rate. That means more than 20% of our tillers are infected. 20% of our plants and our pastures are infected. So we need to talk about what to do now. So we kind of have 2 things we can do. We can replace that stand like Dr. Lacefield talked about, or we can manage that existing stand. And there's some considerations to think about to make that decision. And some of those considerations for stand replacement include, do you own that farm? If you're renting a farm on a short-term lease, then you probably don't want to make that investment in replacing that toxic stand with a novel endophyte stand. Pretty simple, right? Are you using good grazing management? Dr. Lacefield showed a great diagram on how much more tolerant to grazing novel endophyte tall fescue is compared to an endophyte free. But the problem with the novel endophyte is the animals don't get any negative feedback during the summer months. So when animals graze a novel endophyte tall fescue, they'll tend to eat more of it and they'll tend to graze it closer because they don't feel bad. They don't have that vasoconstriction going on. They don't run that low-grade fever. They feel better. And I'm a good example of that. Over Christmas break, I had a toothache. Well, I didn't feel real good, right? So I didn't eat that much over Christmas break. While you all were gaining 10 pounds, I lost 10 pounds over Christmas break. Same way with cattle. When they feel bad in the pasture, they're eating less. That means they're not going to graze those stands as severely. And that's one of the reasons toxic tall fescue survives in pastures. So if you're not implementing rotational stocking and have no plans to implement rotational stocking, then maybe a novel endophyte isn't the right choice to include in your grazing system. Your livestock class. Now, including a novel endophyte is a no-brainer if you have high-producing animals. So if you're in a stocker production system or a grass finishing system or a dairy grazing system, then the novel endophyte should not even be a question. That should be something you include in your grazing system. If you're in a cow-calf system, you've got to think a little bit harder about it. I'm going to grab my water there. All right. And then stocking rate. You know, one thing we don't talk enough about is stocking rate. If we're overstocked and we have no plans on dropping our stocking rate, then probably installing a novel endophyte or replacing that toxic stand with a novel endophyte may not be a good choice. So you've got to be stocked properly at a sustainable stocking rate. So if you meet all this, you own your farm, you're using good grazing management, you got high-producing livestock, and you're properly stocked, making that replacing that tall fescue with a novel endophyte is probably a pretty good choice. Let's talk real quick about replacing stands. And if you really want to learn how to do this in detail, you need to come to the tall fescue novel endophyte workshop that we'll be having in March. And this is some data, and Gary showed something very similar to this. But this is the real deal. Animals do better on novel endophyte fescue in trial after trial after trial. Not sometimes, all the time. And we're looking at anywhere from a pound to a half a pound of increase in average daily gains. So this works in grazing systems. So this is kind of the latest chapter in Dr. Lacefield's book in terms of the tall fescue story. They removed that toxic endophyte and replaced it with a novel endophyte, so the genetics of the plant don't necessarily change, it's the endophyte that changes within that plant. And again, it's important to remember that this is going to require a little bit higher level management. It's tougher than endophyte free, but it's still going to require a little bit more management to keep it in stand because animals don't have that negative feedback. So Ray did a good job talking about novel endophyte varieties that are available and how to use our variety testing program. And there's a number of novel endophyte varieties that are on the market now. And that's going to become the norm, I think, as we move forward. When I started in forage extension 20-some years ago, there was one on the market. And now there's 7 commercially available varieties that you can choose from to use. Now, Ray didn't mention it, but one of the things that are important to remember about these varieties is that these companies are guaranteeing that there's an endophyte in that plant. So when you buy a bag of that seed, you're not only getting that genetics in that seed, you're getting a live, viable endophyte in that plant, or in that seed. And again, we need to manage these under rotational stocking, ideally. And I just wanted to give Gene, Ray recognized Gene, but this is Gene Olson. He's the guy that does all this work on the variety testing. Ray and I's name are on it, but Gene's really the guy doing the work. So if you ever see Gene in the hall somewhere, thank him for all the work he does on the variety testing program, because it's tremendous. And he's getting a little bit older, and Ray and I are dreading the day he retires because I don't know how we're going to replace him. All right, so one approach to replacing toxic stands is what we call Spray-Smother-Spray. And Dr. Lacefield went over this, and I've got it in a little bit different form here. But what we do is we go in the spring and we spray out an infected stand. Okay, ideally we do not let it go to seed. We want to keep it from going to seed. So we can graze it or we can hay it in the spring, we let it regrow and then spray it out. We come in, spray it out with a non-selective herbicide like glyphosate, and then plant a summer annual in there. The nice part about this system is that we're getting some grazing during the summer months during this transition from a toxic to a novel endophyte. So we plant that summer annual and we can use that summer annual. We can harvest it for forage, for baleage, or we can graze it during the summer months. And if we use something like a sorghum Sudan grass, we can probably graze it 2 or 3 times during the summer months. And that's going to give us some good quality forage during this transition period. We come in, we do one more spray. That spray is going to control any of the summer annual that's left. If anything else is germinated or we had any misses or skips with our first spray, that second spray will catch that and kill those toxic tall fescue plants. Since we didn't let it go to seed, there's less of a chance that we're going to have a lot of seed germinating in that stand. And then we plant our novel endophyte in the fall. Generally speaking, when we recommend cool season grass planting dates in Kentucky, we want you to do fall establishments. We can do it in the spring, but weed competition is so bad and it gets so hot so fast in Kentucky that a lot of times we don't have good results with spring plantings. So we tend to push you a little bit towards doing fall, late summer, and fall seedings. The second method is kind of similar to the first method, except there's no summer annual, and it's called spray, wait, spray. And so we graze or harvest that stand in the spring to keep it from going to seed. And then we use a non-selective herbicide in kind of somewhere in mid-July. And we spray that stand out. And then we wait. And then we spray it one more time just prior to seeding, and we plant. This is a very effective method. It does not provide you, however, with any grazing during the summer months. The last one I wanted to mention was if we were going to replace a toxic tall fescue stand with something else, say a summer perennial grass. And this is when we start in the fall. And we spray out that infected tall fescue stand and we plant a winter annual. That winter annual could be something, most likely a small grain, wheat or cereal rye or something like that, a triticale that we would plant in the fall. We come in, we can harvest or graze that in the spring. We do one more spray, and then we can plant our summer perennial grass. So if we were going to plant Bermuda grass or a native warm season grass, this may be a viable approach to introduce to getting rid of the toxic tall fescue and planting that summer perennial grass. So just a little bit on alternative forages. We've got summer annual grasses that we can use in these systems, things like sorghum species, that would be Sudan grass, sorghum Sudan grass. Pearl millets, crabgrass can also be used as a summer annual grass in these systems. We've got winter annuals. We could use annual ryegrass or small grains. In the Spray-Smother-Spray system, where we plant a winter annual, ideally you would use a small grain and not annual ryegrass. And we can use brassicas, or there's also winter annual legumes that we could use in mixture with these winter annual grasses. And the last one I wanted to mention was warm season perennial grasses. As our climate changes a little bit and we see our winters not getting quite as cold as they used to, some of these things that were better adapted in the southern United States are starting to move a little bit north. And if you move into western Kentucky, it's hard to find a pasture that doesn't have some Bermuda grass in it. You can also use native warm season grasses like eastern gamma grass or switchgrass or Indian grass. And then we'll even see some volunteer Dallas grass, which we usually find a little farther south, creeping into pastures. And then, of course, we find a lot of summer annual grasses and pastures, such as crabgrass, foxtails, and so forth. All right, so we talked about a low endophyte infection and just managing those pastures. We talked about a high endophyte infection and replacing those pastures. And now I want to finish up talking about what we do if we decide that replacement isn't a good option for us. So things to consider: if you're working on a rented farm with a short-term lease, you probably don't want to make that investment in a novel endophyte tall fescue. If you have a continuous stocking system, so you're not rotating your pastures and you have no plans on changing that, don't feel bad about that. I'd like to see you use rotational stocking, but if it doesn't fit into your system and you're not planning on using rotational stocking, then replacement's probably not a good option. If you're a little bit overstocked, and you'll admit it, then maybe switching to the novel endophyte is not a great idea. If you have low fertility and either don't want to increase fertility or don't have the ability to increase fertility, then maybe just managing what you already have would be a better option than replacing it with a high cost novel endophyte tall fescue. And the last thing to consider is landscape position. We don't talk enough about this, but there's some places in Kentucky where we should just not kill a tall fescue sod because it's holding the world together. So that's an important consideration too. If you're on a really sloping, highly erodible land, then killing a good stand of Kentucky 31 is probably not a great idea. So in all these cases, it may be better to manage that existing stand and think about what can I do to kind of mitigate the impact of that endophyte on my production system. And it includes lots of different things you can see here in the chart, and we're going to talk about some of those things as we wrap this up. So let's talk a little bit about management approaches. And the concept that I want you to take home is what we call incremental alleviation of tall fescue toxicosis. That's just fancy words for doing multiple things that are going to help a little bit, right? So we have production here with a toxic tall fescue is at this level. We add a little bit of clover, we increase it. We add some supplement to our pastures, or feed a little bit of supplement, it helps a little bit more. We add a little bit of summer grazing, it helps more in our production system. The idea is that we keep increasing that production by adding more inputs into the system. And this works okay, right? But there's a cost. Every time you add an input, it's going to cost you more. And we'll talk a little bit more about that. In using this idea of incremental alleviation, we can increase production in those pastures. They'll probably never be quite as good as a novel endophyte, but if replacing it with a novel endophyte is not an option for us, this is our next best option. So just adding legumes will improve animal performance on toxic pastures. We've got two sets of bars here. We have a high endophyte, so that's a tall fescue that has a high rate of infection, and then we have a low endophyte. What I want you to notice about those bars is that production increases when we add clover on both of those. So while we increase performance on that high endophyte tall fescue, we also get increased performance from that legume on that low endophyte tall fescue. So if we had a novel endophyte that we put in our grazing system, we put clover in it, we're going to get even better production. And that's important to remember. Clover plays an important role in our grassland ecosystems in the southeastern United States. It's bringing nitrogen in through fixation of the legume into that grazing system that gets cycled through that system. Clipping seed heads. This is kind of an important practice. And there was a question about clipping versus seed head suppression. I think both can work. It's important to understand that the toxins in tall fescue accumulate in different plant parts at different rates. And the seed heads is one of the parts of the plant where the toxins accumulate the most. And that's kind of what this graph shows. Ergovaline is one of the toxins in tall fescue. It's in seed heads at a rate of 3 to 4 times as high as leaf blades. So that tells us that if we want to reduce the amount of toxins that are being ingested by our animals, we need to clip those seed heads off. When we clip those seed heads off, we're removing those from the animal's diet, and that's an important management strategy. The other thing that clipping seed heads does is it causes our tall fescue pastures to regrow vegetatively. And we know from lots of research in the past, this is a very old graph, as that plant matures and it gets a seed head, the digestibility of the plant goes down, regardless of whether it's fescue or orchard grass or Kentucky bluegrass, and the intake goes down. So by clipping those seed heads, we not only remove that toxin, but we're also causing that plant to regrow vegetatively, and that's going to increase forage quality and animal performance when they graze that pasture. Grazing height. This is kind of a neat study that just came out in 2018 from Missouri, and it looks at vegetative tall fescue, and it looks at where the toxins are in that vegetative tall fescue. So no seed heads, just the leaves, and what they found was that close to the soil surface, 0 to 2 inches, had the highest rates of ergot alkaloids, or the toxins in tall fescue. In fact, they were about 4 times higher than if we just moved up in that plant canopy to 4 or 5 inches. This is important to understand because how we graze these tall fescue pastures, if we're in a continuous system, they're going to graze pretty close to that soil surface. That means they're going to be getting higher toxin loads. If we can just implement rotational stocking and get them off of the ground and let them graze it to 4 to 5 inches, we're going to decrease the amount of toxins those animals are consuming. So all these are just pieces of the puzzle, and we got to kind of put them together to reduce or mitigate the negative impact of tall fescue in our grazing system. This is not generally related to tall fescue. This is a study that one of my undergraduate students did this summer, and I thought I'd just show it to you real quick. It's kind of neat. Ray showed the disc mower and how close you can cut and how you can hurt stands of grass. And one of the things we measured this summer is we took a temperature sensor and put it right at the crown of the plant, right at the soil surface. And the crown is kind of where all the new tillers grow out of. When we put a temperature sensor there, and then we mowed those plots weekly at 1 inch and then 4.5 inches. And we measured the impact at those different mowing heights in terms of temperature on the crown of that plant. And what we found that on hot days, we could have a 15-degree difference in the temperature on the crown of the plant. And that's going to put that plant, when it's 15 degrees hotter at that lower grazing height, under much more stress during the summer months. So grazing close not only negatively impacts the animal in terms of toxins, it's negatively impacting the plant in terms of stress on that plant, and also it's going to suppress regrowth of that plant and overall productivity of that pasture. All right, next strategy is what I call strategic avoidance. And Dr. Lacefield did a good job talking about this. We're just avoiding tall fescue during certain times of the year, and it's most commonly done during the summer months. So this is our typical tall fescue growth curve. Bimodal, that just means it's got a hump of growth in the spring, another hump in the growth in the fall, not much going on in the summertime. Usually our tall fescue toxicosis is worse when it's hot. So what we can do is we can bring in another pasture, not the same pasture, but another pasture. We can introduce a summer annual grass. And that gives us a place to go with those animals. Or it could be a summer perennial like Bermuda grass or a native warm season grass. It gives us a place to go with those animals during the hottest part of the year and get them off of those tall fescue pastures, even though we're going to have some lingering effects of the fescue up to 28 to 35 days, 4 to 6 weeks probably. We don't often think about it, but in the fall months, when we're accumulating stockpile growth for winter grazing, we can actually accumulate significant amounts of toxins in tall fescue. And this is just some work from Missouri, and it shows how these toxins decrease as we get into the new year. So they start about mid-December, and as we start getting in freezing and thawing and things cool off and the plant stops growing, these toxin levels will actually decrease. So for us, in terms of management, what this means is if we know we're going to have higher levels of toxin in the tall fescue plant in early fall and late fall, then maybe we start to feed a little bit of hay during that time period and then start to graze these stockpile pastures a little bit later in the year. And by doing that, we can reduce the toxin load that the animal is ingesting. We can avoid tall fescue during certain parts of the animal's production cycle, and probably the best example of that is fall calving. So when we have problems with conception rates in cow-calf systems, if we can move into a fall calving system and we're rebreeding those animals when it's cooler out, that can really have a great impact on conception rates in cow-calf systems. That's a very important strategy, and probably a significant number of you are fall calving in this room. This only works if you have a defined calving season, right? So you have to have a defined calving season for this to work. There was an interesting study out of Wisconsin, and in this particular study, they took 25% of the grazing system. So they had a tall fescue-based grazing system, so 1 out of 4 pastures, or 25%, they converted to the non-toxic endophyte. And then they used that 25% of the grazing system strategically. So they took the animals in about 30 days before breeding season. They put the animals in that pasture, and they were grazing non-toxic fescue. And what they found is when they used that 25% that way, that the conception rates were not significantly different than a system that had 100% non-toxic fescue in it. So instead of doing the whole farm, they could do 25% conversion and utilize that 25% strategically to avoid toxins during the most important part of the production cycle and improve conception rates. Just talk real quick about supplementation. I'm not a big fan of this approach, but there has been work to show that it does increase animal performance. It dilutes the toxins in tall fescue when we're giving some type of a supplement. And the other thing that it does is increase the nutritional plane of the animal, so we'll get better production out of that animal. If we need to supplement at 1% of the animal's body weight, and so for say a cow, that's going to be 10 or 12 pounds of supplement a day. On pasture, is it really practical for us to be dragging that much feed out to the pasture every day? Probably not, or probably won't be fun at least. And the other thing is it can get into your pocketbook pretty fast. So if you're looking at 10 cents a pound for the supplement, multiplied by 12 pounds a day, I mean, we're looking at $1.20 to maybe even $1.50 a day, depending on the supplement cost of the supplement. I'm not sure this is really a practical approach to managing tall fescue toxicosis. Last one Michael talked about some is animal selection. And Scott Greiner gave a really good talk about 2 weeks ago at the American Forage and Grassland Council meeting on genetics for tall fescue toxicosis. And I'll refer you to that talk if you're interested more. He wrote a short paper for it that you can download from the website. Everybody in here knows that some animals in your herd do better on infected pastures than others. And you can see that. You can pick those animals out. And over time, we've indirectly selected for animals that do better in a tall fescue grazing system. Some farms more than others, if you're doing a good job with a confined breeding season, you're keeping good records, you know which animals are open and which are not open, and you're calling those open animals, then you're selecting for animals that are going to do better on tall fescue. You know, if you've got one of those herds where, you know, well, you keep the bull in all the time and because you don't want to miss any calves, right? And you're not sure who calved and who didn't calve, then maybe you're not doing such a great job selecting those animals for resistance to tall fescue toxicosis. Scott showed 3 papers, and there's 3 different genes associated with resistance that have been identified for researchers. There's actually a commercially available test that gives you kind of a score. I think it's like 1 to 5 stars for tall fescue tolerance. It's called T-SNP from Ag Botanica. Do you need to use it? I'm not sure. I'm not a geneticist. Gordon can probably tell us a lot better than I can. But I think if you're selecting animals on tall fescue, I mean, you're going to know which ones are not doing too well. And I'm not sure if you need the T-SNP to tell you that or not. One thing that I will mention is that sometimes, you know, not everybody, nobody in this room, but sometimes we focus so much on one trait that we forget about all the other commercially important traits, and that's not something you should do with the tall fescue trait. I mean, it's an important trait, and I think you should consider it, but you got to consider all the other commercially important traits in your genetic program. And the last thing I'll mention is probably now more than ever, we've got animals that are moving all around the country, and we've got semen moving from here to there, and some animals have never seen tall fescue before, and you bring them in and you put them on tall fescue, and they fall all to pieces. Whether that has to do with the microbes in the rumen, like Michael was talking about, or genes that have been expressed or not expressed, I don't know. But I think it's important that we use locally adapted genetics. So we use good genetics, and we know that those genetics were selected on tall fescue if that fits into our grazing system. Here's my final thoughts, and then I'll be quiet. Tall fescue is by far our best adapted cool season grass, and it truly is a wonder grass. And as much as we moan and complain about tall fescue toxicosis, the simple fact of the matter is we've weaned more calves from tall fescue than any other grass that we have. That's a fact. And we got to figure out how to use this grass successfully within our grazing system. The only true, in my mind at least, 100% solution to tall fescue toxicosis is you take that toxin out of their diet. Okay? You can do all these other things to mitigate it, but the only 100% solution is going to be replacing that stand with something else. And in our case, probably the best choice will be a novel endophyte tall fescue. And it's important to recognize that replacement's not always practical or even desirable in some cases. In those cases, we need to really focus on how do we mitigate the negative impact of that through good management practices. And I'll just leave you with this. This is our novel endophyte workshop. We're going to have one in Spring Hill, Tennessee also. And that's going to get into the details of replacing stands with a novel endophyte if you're interested in that. All right, I'd like to invite all of our speakers back up, and if there's any questions, it's open season on the speakers. Don't forget to put your card in if you'd like to win $100.
I'll walk down the aisle, you put the card in, and after the questions, we'll do the
Dr. Lacefield, Michael, you'd like to come up? Do we have any questions? I know everybody's tired here. Go ahead, Dr.
One quick thing that
These together here and talking to both of them.
one quick follow-up that I think all of us have emphasized, and that's if you're going to go to all the time, the expense to establish an endophyte-free or a novel endophyte, then don't make the mistake of mistreating that early in its life especially. Let it get established well before you start using it. And then the other thing that applies to novel endophyte, just like we've emphasized for orchard grass, is that grazing height. Now you can overgraze it once and get by with it, but if you repeatedly graze novel endophyte variety, any of these varieties, and you continually take them down below that 3.5 to 4 inches, keep taking them down, they will weaken on you and will weaken quick. And it's too valuable to do that. So I think that's something I want to make sure that we all go home and realize.
Chris?
Yes, you talked about like don't graze it down, but what about in the winter, this time of year that you stockpile, does it hurt to graze it all the way down?
Now, Chris asked a very good question. Things are unique. We're not talking about regrowth at this time. We're talking about waiting. So from the standpoint of that physiological trait, no, it doesn't apply. But from the standpoint of all your other things, if you're going to put some clover in there, for example, then that would be a good idea to graze it down. But I'd still don't like to nub it in the ground. I wouldn't want to sheep it, even if it was this time. But that is different, and that's the one time that we can do it without as much damage. In the back.
So the question is should we let a new novel endophyte tall fescue sand go to seed, clip it, and hopefully some of that seed will germinate and come back and maybe fill the stand in a little bit better? In the stocking answer is no, and the reason why is if we have any escapes in terms of toxic fescue, we're allowing that seed to increase also. So generally speaking, the general recommendation, unless I'm wrong, is that we just don't like to see people do that. You'll probably do it anyways, but right, you could, yes, clip it before it produces a seed head.
And it's a really good good hay crop, so just treat it for hay. That's actually a good management to not do a lot of grazing that first year. Some people take a first hay cutting or even a second hay cutting, not get grazed until the end of that next summer.
Yes, sir. So not cross-contamination because the endophyte is only transferred by the seed. So it's not going to get transferred from one plant to another per se. But you would have to worry about if you have viable seed in that hay. Then you could move that viable seed from a toxic hay field into the pasture. Oh, yeah, that's good.
And one other way that we can move that in there is by way of equipment. If we're bush hogging an old field of Kentucky 31 that's already got seed heads on it, and we've got seed accumulated on the bush hog or any other equipment, and move that in, usually we see that as we go in the gate and turn the PTO back on. Once that vibration starts, that's where we see the most. But you can, any way you can move seed, you can move the endophyte.
I'm not sure, Ray, difference in tillering among the varieties. There may be some among the varieties, but probably not among the endophyte.
I don't know of any real difference in tillering between them. I'm thinking of observation. I don't know of any studies that have been done to do that. That's a good question, but.
So management, of course, can impact tillering. So, for example, nitrogen fertilization tends to increase tillers. Grazing height will tend to increase tillers because we modify light, the far light to far red to red ratio, and that tends to stimulate tillering. So if we have a closer grazing height, you know, where it's consistently a little bit lower, we'll tend to thicken stands up.
So if you let something grow up to hay and there's a lot of shading of the base, you know, you're cutting 2 or 3 hay cuttings, you tend not to have as thin of tillers or as many tillers. So grazing regularly, letting it get to be 10 inches tall and then grazing it down to 3 or 4, that's going to increase tillering. That's the best way to try to get really good tillering.
Okay. You have any other questions? So the question is if you bale hay that was from a high endophyte hay field, will the toxin still be in that hay when you feed it out? And the answer is yes, some will be there, but they're not completely stable. We're going to see a pretty significant drop in toxins as as the hay sits.
Typically about half, but when you cut hay in June, if it's at a seed head stage, you've got really high levels, so even half would be an issue. But you do get a little bit safer once it's stored. But once it's in a bale, then it really doesn't change, you know, from whether you feed it in the fall or in the winter or the next spring.
So one exception to that is bale silage. So if I'm making bale silage, we do not get the decrease in the toxins in the ensiling system. So that's for, you're not going to get as much decrease.
Maybe 25% drop in hay, maybe 50% drop. Just relative things from some Missouri work.
Plus, keep in mind the impact of temperature on the decreased animal performance, and you're feeding that hay at a quite different time from when those seed heads are on there in the summertime. You'll have the issues, but the temperature factor will lower.
Yeah. Well, that's right. We didn't talk about the negative impact, but Michael talked about vasoconstriction, and that's what causes when we see ear tips and fall off of animals. It's because they didn't have blood flow to those extremities in the animal. Same way with the feet. When we see tall fescue foot, we just not getting adequate blood supply during the cold time of the year to the extremities.
So if you're seeing some of those issues, then you just dilute the hay. You'd use a supplement, you'd mix it with the other hay. Most of the time, as Chris showed that one data, stockpiled fescue consumed from mid-December through early April is lower levels of alkaloids. But we've had a very mild winter, so the fescues continue to grow. So in mild winters in the past, like one about 3 years ago, we actually still had some levels high enough to cause some issues. So again, if you're seeing animals with some of those stress issues, kind of the opposite effects in the winter than in the summer, but yeah, do some dilution.
Is there any other questions? We've got one more question, then we'll draw for $100. So it's a gradual process, but I think some things that are less well adapted here are becoming more well adapted. We do have a new annual clover called Kentucky Pride. It's a crimson clover. It was selected in Norman Taylor's program at the University of Kentucky that has increased cold tolerance and may be a good winter annual legume to include in, say, a mixture with ryegrass or small grain. Kentucky Pride. Yeah. All right, we got one more question, then we'll draw for $100. So the question was other grasses that have an endophyte in them, and there are many grasses that have endophytes and many different kinds of endophytes. Perennial ryegrass had a particularly toxic endophyte in it at one time that causes symptoms maybe worse than tall fescue toxicosis.
But the forage type perennial ryegrass that you can buy None of those have high levels of endophytes. But if someone planted a turf type, fescue or perennial rye, then that can have issues. Fortunately, fescue is the only one that we really need to worry about. Most of the other endophytes are not causing toxic issues.
All right.
You better go ahead and draw. And I'm going to have Dr. Fly, because I don't think he put a ticket in here, did you? And he's going to be very impartial. He's going to close his eyes or something like that.
Nope.
Okay.
Tony Taylor.
Tony Taylor, you gotta be present to win.
Okay. Congratulations. I was hoping you guys would forget. I kind of like seeing this $100 bill in my pocket.